I'm trying to find these statements.
Okay. Does anybody know where Brian O is?
He's in the restroom.
Oh, okay. We'll give him leave for that.
No real good.
Well, we'll send
Well, I'm
Joanne.
not gonna send Joanne.
I'm not calling.
You got out there in a hurry.
Okay, we're gonna call to order this session of the Idaho Water Resource Board meeting number 6-26. We're having a presentation and a field trip today in the Treasure Valley area. The first item on the agenda is attendance. Do we need a roll call today?
I think we ought to do it.
Okay, let's go ahead and do a roll call.
All right, good morning, Mr. Barker.
Here.
Ms. Cole-Hansen.
Here.
Mr. Gibbs.
Hi.
Mr. McMahon.
Here.
Mr. Olmstead.
No.
Mr. Stevenson.
Here.
Mr. Van Stone.
Here.
Chairman Raybould.
Here. Okay, thank you. We're all present and accounted for. Next item on the agenda is the Treasure Valley drains presentation. We'll proceed our field trip.
Daniel Hope, the water master for the Boise River and Water District 63, is here to lead off, and I think he has some folks with him that will help him present.
Yeah, Daniel, welcome. If you want to introduce your team you have with you, that'd be great.
Yeah, absolutely. Thank you, Mr. Chairman, rest of the board. Good morning. Like Brian said, I'm Daniel Hope. I'm the Boise River Water Master. Presenting with me today, Brian Horsborough with HDR and Mike Schubert with HDR as well. They're handling the engineering side of this project. So let me get it queued up here. I need Justin's help. Please. Awesome, thank you. Yeah, so like I said, this will be a update on the Treasure Valley Water Supply Project. This is a three-phase project to help us address declining drain flows in the Treasure Valley that have direct impacts to downstream users and users across the entire Boise River. So I'll go through the first few slides here, just kind of an update of kind of where it was, where we got to, and then I'll turn it over to Brian to give us an update on the engineering side of the project. So like I said, the objective here was to improve water management by leveraging and collecting real-time data along the Boise River and its tributaries. Tributaries being the drains. Obviously, they return to the river and supply all the water downstream of Caldwell to the tune of about 240,000 acre feet annually. There was some limited monitoring on these, but not enough to gain us a better understanding. And that's what the project being. We want to understand how and why these are changing, primarily declining. And so we're trying to gather that to figure out some mitigation going forward. Three phases. Phase one, which is complete, is the automation of data collection. This was the installation of monitoring sites strategically placed in drains that return along Indian Creek, 15-mile creek, 10-mile and 5-mile drains, all that return to the river. So we've installed these, we've been collecting data. Heather and I maintain these sites, maintain the telemetry and the rating tables and the measuring of these sites. Phase two, which is what we're right in the middle of right now, is the modeling and analytics. That's gathering the data, putting it into the model, and trying to gain a better understanding again of the how and why. We can obviously hypothesize as to why things are changing, but in order to actually put something down to give us an idea, we need the data. And so, which leads us to phase three, which phase three is it's an ongoing, we've kind of been, this has been intertwined with everything. We didn't want to wait till the end to try to find the problem. We had some ideas already in place. One of them will be the re-regulation pond level tour later this morning. So the idea being with after phase two, it can lead us into mitigation and collaboration for the downstream water users. Primarily, everybody aside of one entity downstream of Caldwell doesn't have mitigation options, i.e. storage in the reservoirs. So if a natural flow declines to a point where we can no longer deliver, they don't have an option currently to mitigate other than turning off or the rental pool. And the rental pool isn't a long-term solution for anybody, both financially and water-wise. Currently this year, we don't have any water to sell if we had an issue right now. The demand exceeds availability. So trying to find long-term solutions for this problem. Like I said, phase one complete. That's the equipment installation. We've developed the Voice River mass balance, the trend analysis, and the tributary flow evaluation, which is the drains. Started that, collecting that, and kind of going from there. So I'll turn it over to Brian Hoyborough with HDR. He'll talk about the phase two, the modeling and analytics of this, what we're doing, what they're doing. Like I said, the engineering side of this project. Before I do that, are there any questions for me before I turn it over to Brian?
Board members, any questions? Okay. You're okay.
Actually, I do
Okay.
have a question.
Oh, okay.
Daniel, how much water is in the bank and right now?
For the rental pool?
Yeah.
Yeah, so we don't have any, we have very little in there. We've set aside for some miners and some previous entities that do rent, but we don't have anything essentially right now. Demand is above available in the
Right,
rental
but how
pool.
much water was put in the bank that was
And sold?
yeah,
I have to remember off the top of my head.
in the pool, sorry.
Yeah, quite a bit of that goes to private contracts with Veolia, but the general pool, I'm trying to remember, 2,000 or 3,000. I think is what it is. It might be a little high, but it varies from year to year. Typical years, there is availability in there, but years like this where we have potential droughts or shortfalls of water, obviously that would the year that we are going to have a problem on the lower river, it's the same year we're not going to have the water available. In good years, obviously there's an abundance that could be sold, but it's typically not needed. So
Typically, you were blessed with some timely rains that gave you a good storage allocation, but your natural flow hasn't been there and isn't there now. Is
that is correct. Yes, that April rainstorm really bought us some time. We were looking at some historical low snow amounts, which would obviously twofold. The natural flow would decline, forcing a lot of people to use storage, and obviously the timing of it. Typically, mid-June is our day of allocation, and we're looking at potentially the first of next week as sort of our day of allocation. Substantially earlier, that combined with the lack of snow, essentially. So
a lot of that going around.
Yeah. I spent the last few days with Craig Chandler over in O1 talking about that. So, but very aware it's a statewide issue, and this is kind of a microcosm of what's going on with the drought. So,
Right.
Mr. Chairman, Daniel, does the study have domestic well measurements in the areas of the drains too? And the only reason I asked, I've got a daughter out south of Meridian on Amity Road, and it used to be all farms, and now it's all houses, and their domestic well's a 100-year-old one and not real deep, and it will run like one hose now, and it starts sucking air, and it used to run 3 hoses. So
absolutely, yeah. I might have to, Brian. I believe the Treasure Valley groundwater model is being pulled into this as well. All the data we can collect, he might be able to answer that question a little better. I'm just on the surface side of it, but
yeah,
great question. That's one of the questions we brought up. You know, every year we add more and more domestic wells into our aquifer. So
I don't know the answer because we're seeing it all over the,
exactly, yeah. So
1,000 cuts or whatever.
Yep, 1,000 paper cuts. Yep, exactly.
Mr. Chairman, Mr. Olmstead, the study doesn't look at domestic wells individually, but will account for the impacts of those using the Treasure Valley groundwater model with mod flow, which I'll talk about here momentarily.
All right, thank you.
Thanks, Daniel.
Yeah.
All right.
Hey, welcome back. I
Yeah.
almost inadvertently introduced you as reclamation, but
Well,
glad to see you.
Mr. Chairman, I appreciate that. Yeah, I think the last time I presented to this body was as a federal employee, probably presenting on the Anderson Ranch Dam race. So it's good to be here in my new capacity. I'm honored to be here.
There's still time to help us finish Anderson Ranch.
I believe we have a reclamation representative in the room here, maybe. We can ask him. All right, well, thanks, Daniel. I'll take it over from here and talk about phase 2, which he alluded to. I did want to acknowledge that, as Daniel said, I'm joined here by Mike Schubert, one of my colleagues over at HDR. He is the individual that kind of got this project started from an HDR standpoint and has a deeper technical acumen than I do. So we'll have him address any technical questions we might have. So phase 2, as Daniel mentioned, modeling and analytics, kind of the high level intent of the modeling and analytics component is to project potential return flows to the Boise River with consideration given to things like urbanization, changes to irrigation delivery efficiency, recharge dynamics, as you just alluded to, Brian, and things like that. And so actually, I'm going to pause right here. I'm going to go through the modeling here in a second, but what I want to do first is provide an update on a data visualization and analytics dashboard that we're utilizing in concert with the modeling to help the water district with some of their precision in operations. So this is a diagram of the general architecture that we're using for the dashboard. We know that there's very robust data sources across the valley. This figure shows the sites that Daniel and Heather are currently collecting as part of the phase 1 that they just mentioned. It shows the USGS data that we're all very familiar with. Bureau of Reclamation's collecting data, and then there's some historic water district data as well. And I'm not going to go into the inner workings of the Power BI dashboard that we're using to develop this platform. But the upshot is that it uses these data sources to establish real-time connections to those data. It pulls the raw, unformatted data from those sites and essentially concatenates it into a single platform so that the water district can visualize and use that data for live accounting purposes. Between the existing data sources with USGS, reclamation, and then the new sites that Daniel mentioned, there's currently 86 total sites that are being loaded into that platform. So it's a lot of data. And we're actually working to add a little bit more right now. So again, they're going to have a lot of information at their fingertips moving forward. Again, all available in one platform. This is just a figure that shows the entry screen. Anybody know where that's at?
Boise River.
Yeah, I figured Al would know. Yeah, that's the headwaters of the Boise River. Okay. Again, we're not going to do a live demo today. We're working through some access issues with the Power BI platform. I wish we could do that, but what I am able to show is just kind of an entry screen and then the GUI. So we're working towards full dashboard development, but this is generally what the user interface looks like. It's geo-referenced, as you can tell, on that top left screen. And again, it'll allow the water district to pull single or multiple sites and visualize those and use those for analytic purposes all at one time. We're currently collaborating with Daniel and Heather to refine that platform. We're going through testing mode right now. We're also developing a live mass balance data tab. We're developing data download tabs so that the water district has access to that information. And then we're working on some other kind of operational specific tabs that the water district will use. Our current schedule has us completing the dashboard by mid-August, and then that'll be followed by a technical memorandum shortly thereafter. Daniel, Mike, anything on the dashboard that you'd like to add before I move on to the modeling? Okay. Okay, so back to modeling. Software selection, I can't remember if Daniel mentioned this, but we completed software selection in phase 1. We will use ModFlow for the groundwater component, and that'll feed into a riverware model for the surface water component. And I'll go into more of that, more details on those here shortly, but we're currently underway with model development. We're well underway, and we're on track to have the model ready for calibration in the next couple of weeks. Okay, so starting with the groundwater component. As Daniel mentioned, it builds on the Treasure Valley groundwater model and will use ModFlow to apply what's called an impulse response function to evaluate on 1 mile by 1 mile grids how changes in recharge conditions in those grids might affect and return flows to the tributary and then the tributaries and then ultimately to the Boise River. I'm not sure. Do we have a pointer here?
Yes.
Up arrow? Okay. Let's see. Well, you might be able to see those close enough, but this figure on the right is broken into 1 mile by 1 mile grids. And so essentially what that means is as we change the data inputs for a mile by mile grid, it will adjust the impacts to the adjacent mile by mile grids and affect the head difference essentially. And so as you can see, when you adjust the impact to a grid or a series of grids, say based on urbanization or irrigation conversion, it will adjust all the grids around that and so on and so forth down the watershed. And so ultimately, we'll be able to see the impacts of changing a series of grid or a grid on the entire hydrology in a downstream gradient. So it's a really powerful model to analyze groundwater inputs or effects to groundwater, I should say.
Mr. Chairman,
Yeah.
Brian, how does this model that you're talking about dovetail with the Treasure Valley groundwater model that the department has created?
So, and Mike, I'll maybe ask you to jump in here technically. It uses the Treasure Valley groundwater model as its baseline, and that's where the mile by mile grids have been established. And then we're essentially using the it's a ModFlow overlay over the Treasure Valley groundwater model. And that's how we're able to change the inputs on those mile by mile grids. I don't know if that's helpful, but Mike, anything?
We can't do that with the existing model.
Yeah, so we're using the existing model. The existing model is the basis for developing this impulse response function. The impulse response function takes the Treasure Valley groundwater model and develops the series of relationships associated with reduced recharge in these mile by mile grids and the related reduction in flow in the drains and in the Boise River, and builds that out as a function that can be read into Riverware without rerunning the groundwater model every time we want to run a simulation. So
From a layperson standpoint, essentially what you're doing is using the existing Treasure Valley groundwater model and as a jumping off point to do the analysis that you need to do to figure out what's happening with the drains.
correct.
Right.
Okay. Are there any other questions technically?
Joanne.
Or otherwise?
Is it instantaneous to the Riverware model and changes happen in the groundwater model? Or does it have to be, do you have to actually, I mean, like, could you see, maybe I don't know.
Yeah, no, I
I just wanted to know the existing model, is it have, you have to run the mod where, whatever it's called, the groundwater model in order to see the changes, or is it the handshake?
instantaneous. And so it's, what we're doing is we're actually running thousands of ModFlow simulations to build this impulse response function. Okay, so we're running thousands of simulations so that we don't need to rerun the ModFlow model every time we want to evaluate a specific scenario of, this area goes through either an irrigation conversion or land use development. What we can do then is we can, and Brian, I'll get into this. Essentially what we can do is we can say, okay, that this change to recharge happens. And we know from these thousands of simulations that we're running, we have an estimate based on the Treasure Valley groundwater model of the effect that change has to adjacent drain flows and change to flow to the Boise River. And so right in the modeling world, we talk about both models and things like that. We're not setting this up so we have to rerun the ModFlow model every time we want to do an evaluation. We're running a whole suite of simulations up front right now to build a library of functions that can then be referenced when we want to look at a specific scenario. You're welcome.
We're good.
Anything else? Okay. Back over. Thanks, Brian.
Thanks, Mike. I appreciate that support. Good questions. Okay, I think, let's see, I just talked about groundwater. Anything else on this? Okay.
We're good.
Okay. Thanks, Mr. Chairman. All right, moving on to the surface water component. I mentioned that we'd be using Riverware for the surface water component. So simultaneously to the groundwater modelers getting the handshake between ModFlow and the Treasure Valley groundwater model in place and running those scenarios that Mike just mentioned, we're working on a surface water Riverware model. And that will serve as the foundation for the future conditions modeling that I'll go in a little bit more detail here in a moment. I suspect most of you are probably somewhat familiar with Riverware. You probably at least heard the term. It's used all over. It's used in the Upper Snake. Reclamation uses it very prolifically, which I'll talk about here in a moment. But it's just a really powerful tool once it's developed and calibrated for system operations analysis, water accounting, and in our case, we're going to use it for the future conditions scenario modeling. So I'm not going to go through all these bullets individually. They just kind of highlight the details of the model development. But the one that I do want to again point out is that we were able to collaborate with Reclamation to gain access and use their existing Riverware model for the main stem of the Boise River. That saved us a whole bunch of time to use that as kind of a starting point. So very appreciative to the Bureau for sharing that and allowing us to use the work they've already done. Okay, future conditions or forecast modeling. This is really where the rubber meets the road in terms of what we want to do with this project. So once the Riverware model is developed and calibrated, we'll use it for, again, future conditions modeling to forecast the hydrologic impacts on return flows to the tributaries in the Boise River as a result of a certain number of scenarios. So the scenarios that we're looking at right now are things you can probably imagine. Current city and county development plans, we're trying to figure out what potential development rates might look like and how. So think urbanization. Historic irrigation, we're looking at historic irrigation methods to develop the potential irrigation conversion rates. So in other words, when you go from, the easy one is from drip to sprinkler, how does that affect the groundwater infiltration? And there's a lot of literature on this already, right? We're looking at potential rates of irrigation efficiency upgrades. So canal lining, canal piping, how those affect groundwater inputs. And then the other thing we're looking at is the effect of potential groundwater recharge projects across the valley. There's a number of projects that we know are out there on the horizon. So we're evaluating how those may affect groundwater recharge across the valley. So again, just to put a really fine point on this, the idea is to develop and calibrate the model, the groundwater model and the Riverware model, and then change input conditions based on these scenarios that I just walked through and figure out how those affect return flows to the Boise River. So you may have noticed that I use the word potential quite a bit when talking about these different scenarios we're going to evaluate. The reason is because the disclaimer here is that modeling is not an exact science, right? You've probably heard that many, many times as a board. We are making sure to document all the assumptions that we use to make sure that we can explain those in the future. And then lastly, then I'll turn it back over to Daniel to talk a little bit about the 15 Mile Creek project and set the stage for the tour. Project timeline. I don't expect that you can read this. That's not the point. What I would like you to focus on is the black dotted line. That's where we're at as of this week. This is the total project duration, which ends in September of this year. We're slightly ahead of schedule in terms of model development. No, I'm sorry, we're slightly ahead of schedule in terms of dashboard development, and we're essentially on schedule with model development. And then the future conditions modeling that I mentioned will start sometime in mid-June. We'll start doing some preface work on that. So this is a really exciting time in this project. We're reaching to the point where we're shortly going to be able to quantify any potential changes as a result of those scenarios that I mentioned earlier on the hydrology, the surface water hydrology here in the valley. And that directly impacts the operations that Daniel and Heather do, and will allow them to be more precise in the way they manage the system from year to year to year. So any questions on the modeling and analytics before I turn it back to Daniel to talk about 15 Mile Creek, which kind of bleeds into phase 3 a little bit? Okay.
Starting from that.
Trying to figure out where we'll be later. All right. All right. Appreciate your time, folks.
Just gonna hide this, Daniel. Just get that down.
Thank you.
Mr. Chairman? Yeah, I do have a question for Daniel related back to the modeling and the dashboard and all of this. Now that we get to September and you've got all this great information, what are you going to do with it?
What am I going to do with the information?
Yeah.
I guess I'm not sure what do you mean.
I mean, you got information. What's the purpose of, what Water District 63, why do you want to have all this information?
Yes, okay.
How is that going to help you with your management of the system?
Yes, thank you, Mr. Barker. The idea being real-time changes and real-time adjustments on the river. A lot of it's a timing as things change. I mean, it's if it were as simple as releasing water 100 CFS and we know it takes 8 hours to get to Middleton and there's 100 CFS, that makes the job easy. It's not the case. There's a litany of different inputs and impulses that affect all this. And so the idea being, if we collect all of this data and have this data, we can better understanding of how it works and have real-time changes and adjustments instead of waiting for something to happen, waiting for a drop in Middleton where we have shortfalls in water deliveries, or an increase where we're essentially wasting water, operational loss. We can make the adjustments in real time and collect all that and catch it beforehand. So it's efficiencies in how we deliver the water, the timing issue, and then also with the drains, those are a big influence on the up and down the river. And so the timing, if we see an increase or a decrease from a drain coming, if there's an adjustment to be made before it hits, is kind of the idea. Trying to take the fluctuations essentially out of the river. If we can run it as level as possible, that creates a constant flow to the irrigators, less work on them, less fluctuations in their ditch and potential issues with flooding or drying up people. And the more we can keep our Middleton gauge at the 250 mark, which is what's needed to deliver without wasting water, that much less water we waste. If we keep our operational loss to a minimum, is kind of the idea with this. So operational loss being if we have water overages at Middleton, it adds up throughout the season. That's charged to every space holder in the system. And so what we can control ideally is that number, the less wasted water essentially.
So if, Mr. Chairman. Yeah. So if you've got the ability to forecast, is the anticipation that the water district would then interact with or make comments to the cities and counties about their development plans and about what those impacts would have on the water system, or is that part of what you foresee the water district doing?
Yeah, that's always been part of the discussion, is once we collect this data and we have an idea, if that's information that we feel is good, which we're going to get there, to where if we say, just Canyon County as an example, you have this 40-acre field you're planning to develop into a subdivision. Well, here's what we've seen in the past based on information we've now gathered. Here's what you can anticipate to happen to flows in the area, flows downstream. And that might lead us to whatever mitigation at that point. Is there something they need to do? Is there something they can do? Or does it change their thought process? And maybe there's more downside to developing right here. Maybe there's a better option. And that's kind of where we're going. I mean, we understand now that the urbanization is the biggest driver in the change, both in water delivery, quantity, timing, all of those things. So if we have that information to deliver to the people who do make those plans, the commissioners and such, that, now they have, because right now it's just an idea. We can, hey, don't do that because I think it's going to do this, or we hope it doesn't do this. We give them real information based on real data. That's how you make better decisions long-term. So that is the long-term goal. Yes. Yeah.
Dean,
I have one question, maybe, I don't know if you can answer this. So as you see the development going on in the Treasure Valley and the farms being turned, is the consumptive use portion of it increasing or decreasing, or what do you see?
Yeah, great question. As far as overall river demand, it is dropping very, very slightly. A lot of that, it could be tied to maybe less demand for a potential subdivision versus a farm. But a lot of that is just kind of operations as far as managers. The biggest issue, not biggest issue, I shouldn't say, but it's the timing of it. So right now, farms are taking water, subdivisions are taking water, we're on natural flow. But the issue we're running into is September, August, September, when half the time a wheat field has been done for 2 months watering, but a subdivision doesn't stop. That water goes from April to Halloween. And so the timing is becoming the issue too, generally when irrigations will be cutting down towards the end of summer for the crops, we're maintaining a higher late level flow to supply the subdivisions, which at that time of the year is primarily all stored water. And so that's where the usage becomes more, and we're using the reservoirs more. And that's where try to get the understanding of if there's a better way to manage it that way. Because the water right now is natural flow. It's available to be used. And so we're using it, but the stored water isn't the given, right? If we use it this year, we may not get it back next year. And that's where the long-term usage comes into play. But as far as consumptive use, it's pretty much the same. It's a very, very small decline. So.
I think we're good.
Awesome. Yeah. So one of the first ideas that came up was the idea of a re-regulation pond. And there's a few different options along the river where we have these gravel pits along the drains as they return back to the river. And this is the first one we've identified, 15 miles. So the 19-acre pond, that one is fully developed. It's currently a pond right now. The 15-mile runs right next to. And so the idea being we take the fluctuations in 15-Mile Creek and we put them in the pond as opposed to the river. Right now it goes to the river and it fluctuates 25 to 50 CFS depending on the drain flows. So instead of going upstream in the drain to the thousands of intakes, if we can go to the end and take those fluctuations. So when it's running high, goes into the pond. When it's running low, back to the river, we create a constant flow out is the idea. So we take the fluctuations out of the river, put a constant flow back, and to be able to deliver us 25 to 50 CFS more in that reach of the river. Instead of it going up and down, we have a constant flow. We can't deliver the ups because they don't last. We have to deliver at the bottom. So we'll go here today. We'll come into the drain kind of at the very bottom right-hand corner. There's a paved driveway we'll go down, and as the paved driveway turns right, we're going to go right along the drain onto a ditch bank and drive back to the potential site here. The 40-acre pond is still being developed and worked. There's a lot of semi-activity in there. That's going to be the potential next option for re-regulation or whatever we can do with that site. So this is where we'll meet. We'll be along the drains. We'll be able to see the almost done 40-acre pond, the 19-acre pond that is ready to potentially be used. We are talking to the landowner, Randy, out there. He's willing to work with us. We're doing what all we can to get this all figured out. But we'll go to the site. We'll talk about potential options and what it may or may not look like. So,
Mr. Chairman?
Yeah.
So Daniel, it's gravity in, gravity out. We can fluctuate that by 100-acre feet or what are
yeah, a great question. I don't know if we're quite there yet. I might have to have HCR help me with the feasibility of this. It might be a gravity in, pump out. It might be a pump in, gravity out. That's what we're trying to figure out elevations wise. But the pond being a 20-acre pond, if we're running 25 CFS in there for 12 hours, it'll fluctuate, and then it will do the drawdown. So the 19-acre pond will have some fluctuation, but it's got a lot of room. You guys will see out there, it's got big banks. We're not at the risk. If we run 3 feet of water in there, we should still be okay. But that's going to be part of the engineering side of the feasibility. Yeah.
Operating as now.
Yep.
Okay. Yep. Yeah, Mr. Olmstead. So as the slide indicates, the city of Nampa, they were awarded a water resource board grant to evaluate drain flows, surface water flows, flood flows, looking at riverside gravel pits such as these, and recharge opportunities throughout, recharge and drain management opportunities throughout the Treasure Valley. The city of Nampa has completed kind of an appraisal level evaluation of this project. We can gravity flow. We think what we've worked out is we can gravity flow in and out at this area, and we've got and the total operational regulation volume that we need is approximately 50 acre feet. Is the fluctuation is about 40 to 50 cubic feet per second, which means that the volume within that fluctuation under that triangle is roughly 40 to 50 acre feet. And so that's kind of the operational regulation volume we need. Across these two ponds, if you've got 60 acres, we're talking less than a foot up and down to regulate. So
And that size pond, you're getting some real water quality benefits too.
correct.
Mr. Water Quality Benefits, building ponds.
Yeah.
You should get his expertise.
Follow-up question. So
That's done.
does the amount of water that you anticipate storing fall within the 24-hour rule, so you don't have to have a water right? You won't store more than you'll release within 24 hours?
Correct. This is the way we've looked at this is I guess we've looked at this two ways. We've looked at this as a floodwater capture project, I think aligned with some of the city of Nampa's goals, as well as a regulation project. The re-regulation would not store water for more than 24 hours, right? It's purely regulation. Over the course of the day, we're filling the troughs and shaving off the peaks of that fluctuation.
And that's a daily though?
Yes.
The flows go up and down?
Yes.
Okay. Thank you.
You're welcome.
If those developers need to buy some water after 1932, have them talk to Al, we might have some. They might be able to afford, but a farmer can't.
Okay, back to our regular scheduled program. Yeah,
Yeah, thank you, Chairman Raybould.
okay.
Thanks, Dan.
Yeah, I think Mike covered all that. Are there any other questions?
I think we're okay. Yeah.
Okay. And just as a kind of a logistics, so I think everyone has a map or can get a map. We'll turn off a Lincoln Road, and you'll be driving right along the drain on a paved driveway. And right at the end of the driveway where it turns to the right, we're going to turn down the ditch bank to follow the drain to the left. I'm going to be parked right there. We have a sensor right there. I'll kind of help you direct back. We'll kind of just meander back and we'll kind of be in a line as we head back there, and we can see a couple of different sites back there. So
Dale and I might be lost, so it's the exit at the Nampa Sugar Factory.
yeah, you can take north side all the way across to 2026, and I'm trying to remember off the top of my head, it's a left and a right, and you kind of shoot down over there off of Lincoln Road. Yeah.
Okay, so we're ready to head out?
Yeah, I'm gonna ask
Okay.
Cynthia to explain the logistics for the board members.
Okay. Everybody's got gas in their car?
Budget's been cut.
Yeah, that's right.
Okay.
Okay, well, we have a number of state vehicles that we're going to take out there, and we have two board members, Dale and Joanne, who are going to drive their own vehicles, and we'll have a staff person in those vehicles as well. And Brian, if you want to jump in with Dale, that's fine. Then we have drivers here, Mary Neely, Matt Anders, and Scott King is joining us. So we'll have those vehicles down in the front, down in the parking garage in say 10 minutes, which puts us at 10 till 9 o'clock. And I think we have enough vehicles to collect the rest of us who are driving out with Dale and Joanne. We also have a couple of other people joining us. We've got Ryan from the Bureau. I think we've got some Board of Control folks here. We've got a couple of staff from hydrology joining us who you might be able to probe for modeling questions. And otherwise, we will follow Daniel and our HDR, our colleagues out there. So I think that's it. We have some snacks and water.
All right, I'll
Yeah.
ride with you.
Okay, all righty, there we go. Thank you.
All right.
We got Sasha to release the credit card to be able to fill the tank.
Is there?
We can go back and pick our stuff up there.
Credit?